In problem number 3, we want to multiply. We're going to multiply the negative 3 times the negative 3, and we're going to get 9. And then we want to multiply the radical 4x to the 5th times the 32x to the 4th. So what we want to remember is that big idea, that big idea being if you multiply the nth root of a times the nth root of b, you get to put all of that underneath the nth root symbol. So in other words, if the roots are the same, then you can combine what's under the radical symbols by multiplying all of the numbers together. So 4 is already 2 squared, so we're going to leave that alone. X to the 5th, and well, let's get the 32 over here. 32 is 2 to the 5th, and then x to the 5th times x to the 4th, we'll just combine those. So instead of multiplying 4 times 32 and then end up factoring that out, we're just going to keep the numbers smaller. And then again, just like in problem numbers 1 and 2, we want to break down what's under the radical into groups of 2 here because we're looking for the square root. So we're looking for books of 2 if we use the same terminology as we used when we were sorting cards. So 2 to the 2nd is 2 to the 2nd. 2 to the 5th can be written as 2 squared times 2 squared times 2. And then x to the 5th times x to the 4th. Well, I'm running out of room here, so let me take a little shortcut here. I'm going to write that as x to the 4th times x times another x to the 4th. So all I did was I broke down all of the factors, and so I could visualize how many groups of 2 I could take out of there. So if I have a group of 2 2s, I'd take a 2 out. Another group of 2 2s, another group of 2 2s. Can't take that one out. But here, x to the 4th. Well, that's 2 groups of 2 x's. So I get to take an x squared out. And then also for the other x to the 4th, I can take another x squared out. And then again, leaving in there a 2 and an x. So we have 9 times 2 times 2 times 2. So 2 times 2 times 2 is 8. 8 times 9 is 72. So we take we have a 72 on the outside. X squared times x squared is x to the 4th. And then what we have left again under the radical is 2x. And that's it for number 3. It's as simplified as we can get that. So then for number 4, when we have division, we know that big idea is that when we have the same root on top and bottom, we can put both the numerator and denominator under the radical. So let's think about this here. What's 162 divided by 3? 54. So we could let's write this all under the cube root. Sometimes there's ways we can change what we do. We don't always have to use the same steps, but in this case I can see that 3 goes into 162, so, and then also y squared goes into y to the 5th. So 3 goes into 162 54 times, and so we can cancel. 3 goes into the 54 times, and then y squared, when we divide exponents, when we divide y to the 5th divided by y squared, we're going to subtract the exponents. And so then we get 54 upstairs, and then we also get y to the 3rd, and that's all over 1, so we don't need to worry about the fraction anymore. But 54 can be written as 27 times 2, so I'm going to write that as 27 times 2. This is more of the way I want you to try to get to the point where you don't have to break down the numbers anymore. But if you broke this down, you'd have 3 times 3 times 3 times 2. So we know that 27 is a perfect cube, so we get to pull a 3 out. And y cubed obviously is a perfect cube, so we get to pull a 3y out. So we get 3y times the cube root of 2. 3y times the cube root of 2.